rectangular hyperbola. Okay, so this is the hyperbola that you are more used to, because the rectangular hyperbola is one where the asymptotes are perpendicular to each other. Okay, so the asymptotes were dependent on A and B. So remember our formula, x squared on A squared, take away, y squared on B squared is 1, and the asymptotes were dependent on the values of those B's and A's. Okay? So, with the rectangular hyperbola, these asymptotes are perpendicular to each other. Right, so what can you tell me about the values of B and A?
They'll multiply together, they'll both equal minus 1.
Say again, sorry?
When they're multiplied together, they'll equal minus 1.
Mm-hmm. Yeah. Simply, what can we say about B and A? Well, B and A must be equal. Okay, so when you cancel, you get y equals plus or minus x, right? And that will give us the perpendicular asymptote. 1 times -1 gives us -1. So y equals 1 on x, okay, so one that you're used to is an example of the rectangular hyperbola. So we still have our conical hyperbola as shown there, where the foci lies horizontally, and we have the asymptotes perpendicular, and all the other conditions are essentially, but not all the same. So, rectangular hyperbola. So in this format, okay, so there's a couple of different things we're going to do today. We're going to have a look at this format, and then we're actually going to transform the hyperbola into something that you're actually used to, okay, so like we've been looking at in mathematics. So the rectangular hyperbola in this format has the equation x squared take away y squared is equal to a squared, with eccentricity is always the square root of 2 for every single rectangular hyperbola, okay. Remember, the eccentricity has to be greater than 1 for the definition of a hyperbola. The square root of 2 is certainly under that category in there. And it will always be square root of 2. Alright, so the coordinates of the foci are the same, equation of rectrices are the same, and the equation of asymptotes, because B and A must be equal for it to work, y equals plus or minus x. Alright, because we know that the gradient of the of any general hyperbola, the equation of the asymptotes of that. Okay, so for them to be perpendicular, so B on A times negative A on B must equal -1. Alright, so the reciprocal. Hang on. No. So B on A times negative B on A is equal to -1. Okay, so the equation, the gradient of those two asymptotes, one's going to be positive B on A, the other one's going to be negative B on A, and when we multiply those two gradients together, we should get -1.
Reciprocal?
Sorry?
Reciprocal?
No, because this is the gradient of one, this is the gradient of the other.
So if they're both equal, say
Yep,
if it's 2 times -2 is not going to be -1.
If it's 1,
yeah,
I'll get what you're saying. Yep, I'll get what you're saying. How do we work around that? Because we know that one of them, the gradient of one of them is going to be B on A, and the gradient of the other one is going to be negative B on A. Right?
It would work if it's the first one you have. Negative A on B, that's negative.
Well, that's changing the gradient of the one of your asymptotes, isn't it? Okay, we don't actually want to do the reciprocal. We want to show that when you multiply those two, you will get -1. But I get what you're saying. But theoretically, if they're perpendicular, so if M1, M2, the M1, M2 must equal -1. Alright, let's continue and see if we can get our question answered. So a squared is equal to negative b squared. Oh, sorry, b squared, because we've got two negatives there. A squared equals b squared, so therefore b must equal a. So you can't have 2 and negative 2 because they won't be perpendicular, those two lines. Because one's 2, it'll go like that, and the other one's negative 2, it'll go like that. For either 2 run of 1, so these two are not going to be perpendicular, so it won't match the definition. So that's why we can't say what you just said. Alright, so therefore your equation then becomes x squared on a squared plus y squared, sorry, take away, y squared on a squared, because b is equal to a, so I'm going to replace my b's with a. Okay, so x squared take away y squared is going to be a squared. Alright, that's the formula up top. The eccentricity. Remember the formula with a's and b's?
X squared take away a squared over b squared.
That's your ellipse.
Oh, yeah.
Okay, it's the opposite sign to the formula. Okay. A squared plus b squared on a squared. Alright, but we already know that b is equal to a. It's going to be a squared plus a squared on a squared. So this is e squared, sorry. E squared is a squared plus b squared on a squared. Okay, do you remember your condition? Okay, so the foci are lying horizontally, so a is going to be the more dominant variable. Right, and what does that simplify down to on the right hand side? 2. Okay, so it'll be 2a squared over h squared, which is 2. Therefore, e must be the square root of 2 for all rectangular hyperbola. Okay, now there has been mention in some past exams of what the eccentricity of a rectangular hyperbola. Okay, you can state straight away that it's equal to square root of 2. Okay, you don't have to go through all your working and show that it's the square root of 2. Right, basically if you don't remember formulas, if you don't happen to remember formulas, that you can do that. Okay, so whenever you see rectangular hyperbola, the eccentricity is always negative 2. Okay, so there's your equation for that format. Eccentricity is equal to square root of 2. The foci and directrices are the same as always. Okay, so the foci are plus or minus AE, 0, and the directrices are plus or minus A over E, x equals. The asymptotes what's different because B equals A, the asymptotes are going to be y equals plus or minus x because 1 times negative 1 is going to be negative 1 as required in my definition. Right, so what we want to do is at this present stage we've got this hyperbola. We want to transpose it to this what we used to. Okay, so any suggestions on how I'm going to rotate it? Right, what angle do I need to rotate it? Thinking about your asymptotes. So? Pi over 4, yeah. Okay, so if I multiply a point P, P of xy, okay, if I get that rotated 45 degrees, anti-clockwise, okay, I'm going to get this layout here. Okay, so P, x, y, it needs to be multiplied by 45 degrees. Okay, how can I do that? I introduce complex numbers. So, x plus yi, and I'm going to multiply it by cis of pi on 4, 45 degrees, doesn't matter. Okay, so if I multiply by cis pi on 4, so that's our definition when we did it. Okay, when we multiply by the argument, we form a rotation of the point. So if we do that for all the generic point on the hyperbola, we get a transition into what we're used to seeing. So x plus yi multiplied by cos of pi on 4 plus I sine of pi on 4. Now, cos of pi on 4 is basic angle.
Cos and 1 over
1 over root 2. And sine of pi on 4.
1 over root
Okay, so it'll be 1 on root 2I for the imaginary part. So we're treating this as if it's on an Argand diagram. Right, so both of them are 1 on root 2. That actually helps me because I can factorise the sub. So when I do that expansion, I've just got 1 plus I to deal with. Okay, so expand that out. So we've got x outer, inner, and don't forget I squared is -1. So it becomes a, not a y squared, sorry, it's just a y. So I'm thinking I squared. Okay, so now let's group our real and imaginary parts. So it's going to be x take away y over root 2 with the factor out the front plus x plus y over root 2 I for the imaginary part. Okay, so the real part we consider x, okay, from our topic previously. So I'm going to call it capital X, so we're not getting ourselves confused with the little x, little y. So really I'm introducing the parameter. Okay, so the x take away y on square root of 2, and capital Y is going to be x plus y on root 2. Okay, so it's number 1, number 2. Right, so for our normal hyperbola, y equals 1 on x, okay, so what we're used to seeing. Okay, so that implies that xy is equal to 1. So if I multiply, have x times y, I'm going to have an equation of my hyperbola. Okay, so that's what I'm going to do here. I'm going to multiply xy. So multiply on both sides of the equal sign. So capital X, capital Y. Right, so I've got x take away y, x plus y. The difference of two squares is going to be on the numerator. So x squared take away y squared. And then root 2 times root 2, which is 2 on the denominator. Now I've seen x squared take away y squared before. Have I? Do you remember it? Okay, it's going to equal a squared on 2. In other words, a constant. Because a is constant for your equation, and divided by square it, then divide by 2. Okay, so therefore, now we can set little x, little y. Because we have removed the parameters, which was, in this case, little x, little y. So now I can write it back to what looks more natural. Okay, so focus. Plus or minus AE. Okay, so originally, not this one, okay, not this particular one, because the foci is going to change as well, but for generally speaking, the foci was at that. Right. So, what's the value for eccentricity? Root 2. Okay, so it's going to be plus or minus root 2a, 0. But we've multiplied that by cis of 45. Okay, so we've rotated it 45 degrees anti-clockwise. So it's going to equal the change of the foci. It's going to be root 2a, 1 on root 2, plus 1 on root 2i. Okay, so thinking about your complex number. Okay, this is the real part on the horizontal plane, this is the imaginary part on the vertical plane. Okay, and look at that. Things will cancel for me. So the new point is going to be A plus AI. And that's the coordinate of my foci. Okay, therefore, foci is going to be plus or minus A, comma A. Because when you rotate it, so the foci was here and here, when you rotate it 45, it's then going to go here and here. Hey?
For one, that second last line, how did you go from the coordinates to that?
Okay, this is the coordinate of the focus for a rectangular hyperbola. Yeah, then I rotate that value 45 degrees anti-clockwise by multiplying by cis of 45.
And
Yep.
how is it two different points are of the same point?
Because you think about this one. Yep. Because you're multiplying by cis of 45. Okay, which turns out to be A plus AI. Where is that point on your Argand diagram? A units that way, A units that way. Okay, and then you've got your negative one to consider. It's going to be negative A units that way, negative A units that way. So that's your coordinates of the foci. Okay, so our directricity was originally plus or minus A over E. Okay, so plus or minus A on root 2 for a rectangular hyperbola, so we know that. So, our directrices. So again, let's do our sketch. It was the vertical line down there. When we rotate it, we're now going to introduce a gradient, aren't we? Alright, when we rotate it by cis of 45, we're going to have a gradient. So, it's going to be in the form x plus y plus some constant equals 0. That's the format it's going to be in. Now I'm going to determine what the value of k must be to do it. Okay, but I know that the distance from the origin to the directrix is A on root 2. Okay, so I can use my perpendicular distance formula, and that will help me solve for k. Alright, so using the origin, I'll write down the formula ax1 plus by1 plus c over the square root of a squared plus b squared. Okay, so x1, y1 is the point, a, b and c are the coefficients in the equation there, in general form. Okay, now because x1, y1 are both zeros from the coordinate, it's going to be 0 plus 0. And then c, which is k, that's what I'm determining, over the square root of 1 squared plus 1 squared, square root of 2, must equal the distance from the origin to the directrix, A on root 2. Okay, so the absolute value of k must equal A. So in other words, k is plus or minus A. It makes sense because I have two directrices. Therefore, directricity at x plus y plus or minus A is equal to 0. Y equals negative x plus or minus A. Okay, and that makes sense because what's the gradient from that equation? Negative 1. So if I transpose 45 degrees that way, both your directrices are going to be the negative 1 gradient going that way. You are following what's going on? Yeah? Are you? Do you need to ask any questions? Right, and the last thing we need to look at is where are the asymptotes now? The x and y axis. Okay, because we've rotated the asymptotes which were this way and that way. We've rotated them 45 degrees. Remember, this is the gradient of 1. That's the gradient of -1. When we rotate it 45 degrees, we're going to get the actual axes themselves. The asymptotes at x equals 0 and y equals 0. So, when you have x times y, this is going to be your normal hyperbola, normal as in what you're used to. When you have x squared take away y squared, it is still your conical hyperbola that we looked at this topic. Okay, so you need to know the difference between both of them. Alright, let's try a couple of questions to get that through. Okay, and I've just said that because we've got two different formats of the rectangular hyperbola there. Alright, so we're going to find the coordinates of the foci and the equation of the directrices and asymptotes for the following rectangular hyperbola. Okay, so when you have x squared take away y squared, it is this one. Okay, so foci are here and here, directrices are here and here, and asymptotes are there and there. Okay, so this is just like you've been treating any other hyperbola, this topic. Alright, so what do I need to do first? Okay, what's the format for my foci? Here and here. What's the variables? Yep, so plus or minus. Okay, so what's A? What's A? E is root 2. A is? Sorry?
It's the Adobe's face.
X squared take away y squared equals?
A squared.
A squared. A squared. Okay, so x squared take away y squared is a squared, and that's where you get your A from. Right, so A is going to be square root of 10. Right, and really you are thinking about writing it as the square root of 5 times the square root of 2, because the eccentricity is the square root of 2. So foci at plus or minus, so I've got root 5 root 2 times the eccentricity, which is root 2. So it becomes 2 root 2, 0. 2 root 5, sorry, yep. 2 root 5, 0. Okay, directrices. What's the general format of your directrices? Okay, to foci, A times E, directrices, A over E, and that works for your ellipse as well. Okay, depending on the value for E, whether it's less than 1 or greater than 1, we'll put it in the right position for you. Alright, so plus or minus A was root 5 root 2 over E, which was root 2. Okay, stretch these x equals plus or minus root 5. What's the equation of your asymptotes? definition of your rectangular hyperbola is that the asymptotes are perpendicular to each other. Okay, that is the definition. Alright, so we've got the second one, xy 32. Alright, xy 32. So coordinates of the foci. Okay, so now we've got that shift in the hyperbola. When you're multiplying the constant, it's back to what you're used to in mathematics. Right, so the foci will lie here and here, along the line y equals x. Okay, so foci at plus or minus a comma a. What's the value for a? Sorry?
Square root of 32.
Nope.
No.
xy equals square root of 2. So, a squared over 2 is equal to 32. Okay, a squared 64, a is going to be 8, just for the positive case. Right, because we've already taken care of that. 8, 8 for the coordinates of the foci, plus or minus 8, 8. Oh, that's what I forgot to show you. Oh, bummer, I forgot to put it there. In your notes, and I'm not going to do a proof of this, I've missed out a whole section of your notes, bummer. Alright, xy was a squared on 2. Okay, and you can have a look at this in your notes. Because this is really a constant, we're going to call it c. C for constant. Okay, and in your notes will be the transition from your coordinates of the foci, equation of the directrices, and the asymptotes will still be the same. Okay, that's why. I'll quickly show you that next lesson when I set it up. So, foci at 8, 8. Okay, directrices. Okay, so the equation was y is equal to negative x plus or minus a. Okay, so y is negative x plus or minus 8. And we're at the asymptotes. The x and y axis. Okay, so in other words, x is 0 and y is 0. Okay, next lesson I will show you the other format. Actually, no, I'll show it now.